on the shark bite, which numbers do we want to see, go over, have questions about? And all the ones we can do in desmos, we're going to do all those, so we might end up doing them. So I see a lot of 2, 3s, and 5s. 2 can't be done on desmos. 3 can, but I'll show you that. 5 can, so I'll show you that on desmos. So I didn't see any 1. So we'll definitely do 2. 1 also cannot be done in desmos. That's something you have to know. So we'll do 2, we'll do 3, and then go on to the back. So number 2 is asking about the range. Is that your x's or your y's? Y's. So we're looking for our y values, lowest to highest. What would that be? What do we think that is? Nature? Because this keeps going down and right, and this keeps going up and right, so that would be all those numbers. 3 can be done by hand, but it can also be done in desmos, so we'll do it by hand first, and then go back and show you how you would do it in desmos. So by hand is like what we've been doing. Find the slope of these points, so 0 minus 0 over negative 7 minus 5. So we have 0 over negative 12, which simplifies to be what? 0. And then you have a couple different options. 1 is with work, 1 is kind of without work, and I'll show you both. The with work would be taking the slope, picking one of these points, and doing your point slope formula. So y minus 0 equals 0 times x minus 5. But this just becomes y. 0 times anything is what? So all your other variables disappear. Is that 1130 or 1030? The without work would be to remember your toy box. If I know we have a 0 slope, this is going to be a y equals. Because I know this is a y equals, I can look at what the y values are and jump straight into your equation. Desmos is kind of the same thing. So what you could do is plot these points. Notice that both of these points fall on the same line, on a same horizontal line. So that means you have to know what that means. It's a horizontal line, it has to be like a y equals. But let's say you know it's on a straight line but aren't sure which. You can put in all of your things. Great, so we have an x equals 5, an x equals negative 7, and a y equals 0. So I'm going to put in all of those. And see which one goes through both points. One of these did not go, because it put y instead of x. So the green and the blue go through one of them, but not both, but the purple goes through both, and that would be your equation, yes. Yes. So that would be your answer. That same thing can be said for any time you're given 2 points. You can plot the 2 points, you can count your slope, and then either keep counting your slope till you run into your y-intercept or do the work. So y equals 0 was your answer for that one. Question so far? For number 4, that can be done in desmos if you know what you're looking for. So if I were to type in the equation given, negative 5x minus y equals 1. Now, you could just solve this, and that would work. If you had this on desmos and maybe didn't want to solve it, you would do this. So after you put this in, you have to know where your y-intercept is, and then be able to count to your slope. So I see that another point that crosses the grid line exactly is this one, negative 1, 4, so I'm going to make that point. And if I counted from here, from my y-intercept up, I'd be going up 1, 2, 3, 4, 5, to the left 1. So my slope is negative 5, my y-intercept is at negative 1. So my equation should be y equals negative 5x minus 1. Those overlap. So I know that that is the right answer. Now, desmos only helps you so much. You have to know what you're looking for. So you putting this in only helps you if you know that you're looking for the slope and the y-intercept. But that final equation is your answer for 4. Questions on that one? For 5, as with all equations, you can type that into desmos. It'll solve it for you. I'm going to type that over here.
5 times x minus 3 minus 2x equals 46 minus 4 times x.
So as you type in everything, it will solve it for you and tell you what that answer is. X equals negative 9. So as we get closer and closer to the SOL, knowing how to do this stuff in desmos is helpful for you because you won't have your calculator. So this is good practice, but on tests and things we do, knowing how to solve it is also beneficial for you as well. Questions on this? If you haven't already, take out your notes from last class, the parallel and perpendicular line notes that we started. I did like one problem. Anyone need another one of those? So we did number 1 last time. We're going to do a couple more of these, starting with number 2. So let's go ahead and find our slopes for A and B. I'm sorry, for A, B, and C, D. So AB would be 4 minus 2 over 5 minus 0. What would that slope be? Teacher? 2 over 5. And then do the same thing for CD. 3 minus 8 over 3 minus 1. What would that slope be? Negative 5 over 2. Are these slopes parallel, perpendicular, or neither? Lily? Perpendicular, why? Because they're flipped. One is negative and the other is not. So you can either write out the word perpendicular or use this symbol, the upside down T. Questions on that one?
Instead of pushing about that one, but is there like a specific sign for parallel?
Yeah, it was this.
Oh.
That's all. Alright, let's do number 3. Same thing, find your slope for AB and your slope for CD. What is your slope for AB? Negative 2 over positive 3, or just negative 2/3 total. Find your slope for CD. 3 minus 2 over 3 minus a negative 1. What would that slope be? Cameron? 1 over 4. Are these slopes parallel, perpendicular, or neither? Neither. They're not the same, so they're definitely not parallel. One's negative and one's positive. For perpendicular, yes, but they're not flipped of each other, so they're neither. Neither. However you should say that. Some other neither or neither cases, if they had the same number, so like say it was 2/3 and negative 2/3, those would be neither because even though they have the same number, they're not the same because one's negative. If you had one that was flipped and the other, so like 1/4 and 4, but they were both positive or both negative, that would also be a neither case because you don't have one that's negative and one that's positive. Or any other combination of those things. Okay. What questions do we have so far? Some of you may have started on 4, but we're going to skip to 5 on the back. Go ahead and find the slopes of both AB and CD. And I'll give you a minute to do that. Okay, before you tell me what it simplifies to be, or the actual answer, what would this be? 9 over 0. What would CD be? 0 over 3. As is, are these parallel, perpendicular, or neither? Okay. So that's what I thought you would say. Let's see if we answer this really fast. We have to remember that anything over 0 is what?
Undefined.
Undefined. And 0 over anything is what? 0. What are 0 and undefined? Parallel, perpendicular, or neither slopes? Perpendicular. So that's going to be one that trips you up if you don't remember what those look like. So before we left, I was mentioning that these are the type of problems you need to be careful about, because if you don't switch these to undefined and 0, you may get the wrong answer. So be careful with that. Questions on how to find if these are parallel, perpendicular, or neither from slopes? Now we're going to switch gears, and now we're going to be given equations. So we're going to start at 9 and have to do the same thing. For number 9, would these be parallel, perpendicular, or neither? Really? Why? And what's the other part? They have to have the same slope and different y-intercepts. Because of that, these are parallel. That was supposed to be a circle. So you can do the symbol or write out the words parallel. Write out the word parallel. Either or. Would 10 be parallel, perpendicular, or neither? And why are these perpendicular? So opposite sign, and they're flipped. What about 11? Nature? Neither. Because even though they have the same number, one is negative. So this is a neither case. 12, we would have to solve before we could figure that out. So let's do that. I have to get this back into slope-intercept form. How would I do that? Nature. So I'm going to switch this first, so negative x plus 30, and then divide everything by 6. What is that new equation going to be? Y equals negative 1 over 6x plus 5. Then for the second one, it's almost solved. We just have to divide everything by 3. What would that new equation be? What would that second one be? Really? So would these be parallel, perpendicular, or neither? The slopes are flipped. One is negative. Those would be perpendicular. I want you to try number 14. And I'll give you a minute or two to do that. So these should have been the two equations you found. Y equals 3x minus 2 and y equals 3x minus 1. Are these parallel, perpendicular, or neither? Neither. Would 15 be parallel, perpendicular, or neither? Really? You have a slope of 1 and negative 1, and those are negative reciprocal slopes. What about 16?
Major?
It would be perpendicular. You have to think about your slopes. Because this one's 0 and this one's undefined. They would cross, so those would be perpendicular. Because they're simple enough, you could also graph it. Maybe off to the side. So if I made like a makeshift graph, and I said x equals negative 1 was here, and y equals 6 was here, I could see that they cross and they make that T. Before we jump to the next thing, how do we feel about finding equations? Nope. Finding if they're parallel, perpendicular, or neither from equations. Good. Okay, need more practice. Excuse me, not good. I don't understand this out. One of your Khan Academies for next week is this, except they have a couple more options. So they'll have distinct parallel lines. They're parallel lines. Distinct perpendicular lines. They're just perpendicular lines. Then the other two options are the same line or intersecting lines. So the same line is they look identical. Y equals 2x plus 1 and y equals 2x plus 1. They will be identical. Intersecting is like your neither case. They're not parallel, they're not perpendicular, they're not the same. So they just intersect at some point. So keep that in mind when you go to do that. Skip the next page. I know that says parallel, perpendicular, or neither. That's something for you to practice on your own if you so choose. Find this page. So now we're going to be doing like what we were doing before with writing and tying it into parallel and perpendicular lines. So we have to remember two things. Parallel lines have what type of slopes? What do we know about their slopes? They're the same. And perpendicular lines have what type of slopes? Or what do we know about their slopes? Really? More to it. There's a specific set of words, 2 words, something reciprocal. It was on the first page of your notes. Negative reciprocal. One is negative, one is positive, and then they're flipped. Right? So with this, we're going to be given an equation. We have to write another equation that is parallel or perpendicular to the one we were given. We're going to be given a point in an equation and have to use that to find our other equation. So, with this first example, we're given this point over here. You can label it x1, y1. We're given this equation. The only thing we need out of this equation is the slope. If you want to cross out the y-intercept, you can. We don't need it. It will just confuse you. It's just there to show you the equation, that's all. Of our new equation, it has to be parallel to this one. So what would that slope be? Feels like a trick question, but it's not. If it's parallel, and we know they have to be the same, what would that slope be? Say it louder. -4. So right now, it doesn't really make sense to write this, but it will make more sense. It's good practice for when we get to perpendicular, because you'll need to do this. So now we have the slope that we're going to use and our point. Off to the side, if you want to write your point slope formula, because we're going to be using that. So then we're going to put this slope and this point into this and solve. So y minus 7 equals -4 times x minus a -2. Or if you want to go ahead and make that a plus, you can do that. Remember that the only time that becomes a plus is if you have a minus minus. What's our next step? Distribute. We have y minus 7 equals -4x minus 8. And then our last step. Add 7 on both sides. We have y equals -4x minus 1. And then as we look at these two equations and compare them, y equals -4x minus 1 is the one we got. It is parallel to the original -4x plus 1. They have the same slope, but different line intercepts. If I graphed both of these lines, they would never intersect, or shouldn't. What questions do we have so far? Let's try example 2. So example 2 is a little different because it's not already solved for you, the equation. So we have to do that first and then do the rest of this process. I'm going to do this off to the side. Get this back in slope intercept before you do anything else. So get rid of your x by subtracting. Divide -3 to everything. What would this new equation become? Nature. We have an equation, but that is not the answer to the problem. That is just us rewriting what was given back in slope-intercept form. If you want to cross out the -3 so you don't confuse it with anything else, you can do that. If we're writing a new equation that is parallel to this one, what would the slope be? Really? 1/3. So now you have your slope, you have your point, use your point slope formula. We have y minus -1 equals 1/3 times x minus 3. I'm going to distribute this and make this a plus at the same time. So y plus 1 equals 1/3 x minus 1. And then subtract 1 on both sides. so far? Do we have any questions about this process? Answer, anything like that? Because we're going to change gears. Similar process, or almost the same, with perpendicular, but it's a little different. There's like an extra step in there. So with perpendicular, for example number 3, we have our point just as before. We are given the equation just as before. But if our new equation is perpendicular to this one, what will that new slope be? -1/2. So we have to change the slope before we can do anything else. If you don't change the slope, all of your work is going to be wrong. So that has to be step number 1. If it's already in slope intercept form. Great. Process that y-intercept if it bothers you. Then the process is the same. You have your slope, you have your point, put that into your point slope formula. So y minus 3 equals -1/2 times x minus 4. As you keep going, you should get y equals -1/2 x plus 5. You should see, if we're comparing the two, that these are perpendicular to each other. The slopes are negative reciprocals, so y-intercept doesn't matter. What questions do we have on that problem? For this next one, this is similar to example 2, where you aren't given it in slope intercept form, so you have to solve that first. You can do that off the side. So as I'm writing, you should be continuing to start this, not waiting for me to write it. So once you get this back in slope intercept form, your equation should be y equals -5/3x minus 7. What would the slope of our new equation be? And then you do the same process. So your slope, point slope, with your new slope and your order vector. Y minus 1 equals 3/5 x, parentheses x minus a -5. Or change it to a plus. Keep working that. When you multiply 3/5 times 5, what do we get? 3. And then add 1 to both sides. If you forget to switch your slope first, and you use the wrong slope, your work is going to be wrong. if you remember at the end that you need to change it and you change it back to 3/5, your y-intercept is going to be wrong. So you have to do it at the beginning. Overall, how do we feel about writing equations parallel or perpendicular when given an equation or an a point? Good, okay, not good. Okay. So I'm going to have you do 2 problems, and then after you do these 2, you can work on Khan Academy. More practice on this. I'm going to be passing out a study guide review because your quiz is next class. On the back of this, there are 2 sections. One is parallel, one is perpendicular. I want you to choose one from the parallel and one from the perpendicular, but one of them has to be one where it's already solved, and the other has to be where you have to solve it. So if you choose the one where it's already solved in parallel, you have to choose the one that's not solved in perpendicular. So I'll let you make that choice. Once you finish one from each section, raise your hand and I'll come and check it.